Okay, that is pretty vague, but it's giving you two vectors that should be added together. So those technically could be anywhere. They could be on any spot on this graph. So like for instance, 2, 1, that could be here, and this is where I would want you to eventually put it. But do you get that it could also be like there, and it doesn't matter? That's one of the things that's hardest to get about these vector problems. I'll give you an example of why that matters. Because if you had a, for instance, parallelogram that went like this, I got to keep this parallel. There we go. A, B, C, D. If I asked you for AB plus BC plus CD, you should say that the answer is A, what's left? A to D, this red one. But what if that wasn't one of the choices? There's another vector that's exactly the same. It's not considered different at all, that, because that and that are headed the same direction. And so therefore BC, I didn't draw it perfectly, otherwise it would be lining up perfectly, but BC is the same thing as AD. All right. I'll show you later how you can do these without the drawing even. All right, so back to this. We have 2, 1, and then we have 3, -2. I'm going to put that some other random place where I'm going to start here, and I'm going to go 3 to the right, but down 2. So then it looks like there. Oh, rats. There. Okay, now, I'm just trying to make the point that this doesn't have to be, stop at the squeakiness, there. It can be a lot of different places, but it's the easiest when you put it there. It makes the most sense. And then you can get your answer and say, oh, so you're saying you want me to go first to here and then to there. And so then it would have been the shortcut. I like to think of this as a shortcut. The shortcut would have been just to go from there to there. And that's the answer vector, also known as the resultant, that dotted line. And it could have been found just by doing this. 2 plus 3 makes 5, and 1 plus -2 makes -1. And didn't I go over 5 and down 1 when I did this black dotted line? Yes, I did. All right, one more thought. I know its direction. It's kind of the direction that it's going right now. Okay, it's this direction, like this. But what's its magnitude? How long the line is tells you the magnitude. So what's the magnitude? Well, I'm going to zoom in on just that triangle. I'm going to pull it over here and say it goes over 5 and down 1. Do you get that that is 5 and that is 1? And then how long is this then? The actual vector is not 5 and it's not 1, and it must be longer than both of those because it's the longest side. Square root of 26. All right, so that's its magnitude. This guy right here, magnitude would be the square root of 26. Okay, so a few other little terminology things. Oops, erased too much. I'm going to call this A, and this B, and this C. Then do you get that AB plus BC equals AC? Okay, it's as simple as you would think. What do you think I mean when I say AC, but I put bars around it? Absolute value, but that takes away whether or not it's negative, which means it takes its direction away. All right. So that means take out the direction and just tell me, well, what's left if you take out the direction? It's magnitude. All right. And that's, in this case, square root of 26. Okay. Next concept that you need to understand is, what if I said double AB? I want 2 ABs. Well, when AB was like this, and I'm going to actually use the cloning feature of the smartboard to show you it's exactly double. See? 2 of those. There's 2AB. I'm going to get rid of the rest of this problem here. 2AB would be 2 of those. It's basically in the same direction, but double the what? Magnitude. Okay, so that's 2AB. And then let's say I decided to call this little guy, here, I'll make it green. That's going to be a vector too. Can it be a vector? Does it have magnitude? Yeah. Does it have direction? Yeah. So then that's a vector. I'm going to take that guy and put him right there and say, I'm going to budge this back a little bit. There we go. That'd be like 2AB plus, well, I got to give this a name. I don't have to call it like AB. I could call it like R. I could say 2AB plus R. All right. So if you're going to double something, you just put 2 of the vectors back to back. All right. Now let's see if you can handle this one then. All I need you to do is draw me a picture of this. If this is going to be my vector, I'm going to call it vector AB. And then this is going to be my vector BC. Would you please tell me what 2AB minus BC is? I'll write that out. 2AB minus BC. Pause for a second while you try that one. All right, so here's 2ABs. I'm going to put them here. Do you have to? Nope, you don't actually. It's just much easier to read the answer if I start at the origin. So I made 2 of them. There's 2AB. Minus BC. Well, here's BC. But what's going to happen if I do that? That's actually 2AB plus BC. How do you do a minus of a vector again? What do I change? Its magnitude? Direction. So I'm going to rewrite this and remove the red one and replace it with the blue one. That way, my answer will be there instead. That's 2AB minus BC. The minus just makes it go in the other direction. Final answer will be this, which is the column vector I could call 2, 3. I could also call it 2i's plus 3j's. Because it goes, this green one goes over 2 and then up 3. Okay. Or, since I called this A, B, and this was also A, B, that's weird, because you got a B and an A at the same spot, right? And then this was B to C, then I could call it CA. Oh wait, AC. Do you get that AC and CA are different because they go different directions? All right. We're getting close. You don't have to actually know too much more. So there is more, of course. All right, I'm going to give you, this one is the one where you don't have to know what the vectors look like to give the answer. What's AB plus BR? Well, I'm going to make them vectors. Don't forget, if I put a little line over it, that means vector. Vector. AB plus BR. This would not be a fair question. What does it look like? Because you can't tell. You don't know where these vectors are. What would be a fair question would be, what's the name of the resultant? My best advice is draw it anyway. I know you don't know what it is. Just make something up. I'm going to call this AB. I don't know. Could be that. And then I'm going to say, if that's A to B, then BR would go like this. And again, I can draw it anywhere I want. I'm doubting anybody made theirs the same as mine. But it doesn't matter. As long as I label all the points right, I know my answer is AR. Raise your hand if you had AR. Awesome. Okay, some other things that could happen. What if I added one more thing? Plus RA. I think you know that the answer is that I've gone back to the origin, but I'd wonder if you're going to know how to say it. Should I say AB? No. That's a totally different thing. 0 is close. Just A is close. First of all, the answers to all vector problems need to be vectors. So it's vector 0, and that's what you call it. It's vector 0. It's also called the 0 vector. Now, one thing that every vector has to have, actually, sorry, two things every vector has to have. It has to have distance. No, it doesn't have to have distance. Direction, and what's the other thing? Magnitude. Okay. So does this 0 have a magnitude? Yes, the magnitude is 0. I know it's kind of cheating, but its magnitude is 0. And how about its direction? What direction is 0? That's weird. I could see how mathematicians might have defined that as like, it's just going to be north because we have to pick one. But they actually did a kind of interesting answer. It's 0 in what direction? All directions. That's it. 0. And its direction is every direction. So how do you write it? With the 0 with a little vector thingy over the top of it. Notice that's not a ray. You actually see these sometimes in our notes because there is no like symbol that's built in. Like there's so many math symbols, right? They've even got lots of them. They got some of the weird ones, the integral ones, and the big summation things. I'm drawing that wrong already. Like this. They have those kind of symbols, which you'll need in calculus and stuff, but they don't have the vector symbol. At least when we were typing this, they didn't. So that is technically supposed to be, since you can draw it any way you want to, that. I don't mean you can draw it any way you want to. You don't have the constraints of a font or not having it in your program. So please try to label it with that kind of an arrow. I'm not saying I would mark the whole thing wrong if you had two tip, like the double-sided tip. But know that that's how it's supposed to be. And what direction is that in again? All directions. Yes. So if I move this whole thing like here, I want to know what your guess is. Do you get that those are all the same vectors? Because they're all in the same directions and all have the same magnitudes and stuff. So what's your gut? Do you feel like the answer should still be the 0 vector? You are right. Even though it's not at 0, 0, the answer is still 0 vector. Okay. So let's see if you can handle this. No picture. Remember, it's like last time. I made a picture. I faked it. You can do the same thing. All right. Tell me what's AR plus RA. Makes you think, doesn't it? I recommend you put AR on your page. How do you know what it looks like? You don't, so you just make something up. There. I'm going to call that AR. And then now I have to do RA. And if I've defined A and R as being those spots, then RA is like that. What do I get when I add those back together? You're back at the home spot, so that's called the zero vector. So zero vector. That's zero in every direction. Okay. Now how about if I said this? Tell me why I should use a lowercase a or an uppercase a here. Sorry. Why could you not do that? You'd have to what? Yeah, you'd have to know the distance. We don't know how long AR is in the first place. Okay? So how do I supposed to know how long two of them is if I don't know how long one of them is? And how do you know that this question is how long? Because I did the absolute value bars. That means strips out the direction, and all of a sudden I don't even care about the direction. I just want the other thing, which is the magnitude. All right. Now this one, you should be able to draw and answer. Okay? Node line, sorry. I want you to find that and then do that. Two one minus 3 4 and put the bars around. I'm going to pause for a second. Let me try that one. That green one, that's what 3 4 would look like. So why don't I do this? Because that would be adding those two. So now I'm going to go the opposite direction, which is like this. So why can't I leave the answer like that? You never do point to point. We call that head to head. You never do that. That was head to tail. So there we go. And then you might think that this is the answer. And it kind of is, but that's the vector. But what did I ask by putting the bars around it? I asked for its what? Its magnitude. By putting the bars around it, I'm saying I don't care what direction it's in. I want to know how long it is. And the common mistake answer is that that's 3 long, but it's not. If I blow up and kind of zoom in on this little triangle I could make right here, it will be, and this is 1 and this is 3, and that's not 3. It's the square root of, not square root of 2, no. 1 squared, 3 squared, and then you do the square root, so square root of 10. That's how long that dotted line is. That dotted line would be the square root of 10 long. Now, I'm sorry I drew it in a different orientation. I wasn't wrong, but it would be easier to see if you guys see it this way. Well, you know what? I'm just going to do it right on the spot where it is instead of bringing it out. I'll just say it's over that far and down that far. And then I can say it's 1 on the one side and 3 on the other side, and therefore square root of 1 squared and 3 squared, square root of 10. How many of you, be honest now, I know I got the feeling some people got lost in there. How many figured that one out before I said it? All right, that's only way less than half the room, so let's try one more like that. Do you get how I made a picture for it? And at the end, I figured out how long the line was. How did I figure out how long the line was? I used right triangle. Try that one. Okay, anyway, so here is a classic mistake answer. The kid carefully does 2, 5, and 1, 1. What are they doing wrong? They're adding. Okay, so I'm going to go the opposite direction. I'm going to make this go this way instead. Next easy mistake to make is that. And they at least got the direction reversed, but they are lining them up wrong. They always have to be head to tail. So then this has to go like that. And there we go. And then next mistake, again, pre-calc. Complicated. Not super easy, because I had to do all these steps right, and there I've got the answer. No, I don't, because I've got the picture of the answer, but what did I actually ask for by putting the bars on there? Yes, the magnitude. And that's the official name. Distance would have kind of been right. All right, then this, I need to know this is 1, and this is 4, and 1 squared and 4 squared is 16, and 1 makes 17. Square root of 17, raise your hand if you had that one right. Okay, awesome. You're getting smarter. So, since the beginning of the year, you are a lot smarter than you were, if you think about that. And many of you guys are in that, let's say 16 to 17 kind of zone. Let's call you 16. But I know there's differences in here. And some of you are like, I'm 19. Oh, anyway, whatever. Just pick a number. Pick a number. And if you take that and you say you are 1 whatever, you can say how much smarter you are than you were a year ago. So, for example, let's say that you are now 16. You are 1/16 smarter than you were a year ago. Or you could even argue that you take 15 was your total age, you just increased that by 1, and therefore it's the change divided by the original, so it would be 1/15 smarter than you were last year at this time. Now that assumes, though, that your intelligence just keeps growing at the same rate over and over and over again. And it doesn't. It's kind of lumpy. There are times, I don't know if you've felt this, I remember feeling this as a kid, where it's like, I think I actually got a lot smarter over the last, 6 months. And there's other times where you just kind of, stagnate, maybe even get worse. So, stupider is not a word. So, one of the reasons is that you get coats of myelin on your brain. And that's one of the things that makes you, the big difference between a child's brain and an adult's brain. If you look at the two, the adult's brain is much more gray. Why? Because it gets extra myelin, these coats of myelin on your brain. And all of a sudden, it doesn't just happen overnight, but there will be a time where all of a sudden, your brain just added another coat of myelin. And that's like adding an extra layer of ice to the hockey arena. At the beginning, there's not much ice there, and the puck, which is like thoughts, can't go very fast. Okay, but as you get smarter, as you get more myelin, it's like getting more ice on the rink, and the puck, which is like a thought, can shoot around the rink a lot faster. Yes? Oh, interesting. There is definitely those zones, but I think we'd have to. Now, I think we're gray matter versus white matter is the question. What I was referring to is myelin, and so I don't know if you're right or I'm right or some combination of the two. But I know that if you look up myelin, that was kind of a moment for me when I was like, why do kids, some kids in my class are just the same age, but some of them are just so much smarter than others. And is it just genetics? Well, sometimes and some of the kids have gotten an extra coat of myelin in, and they're a little more advanced compared to their peers, and then they might catch up. It always makes me sort of like growth. You can have growth spurts with your brain too. You have people who grow in college, like Michael Jordan grew 9 inches in college. And most of you guys are done growing now. And he didn't even really have his major growth spurt until he hit college. And he grew 9 more inches. Well, some of you guys are going to be the same way intelligence-wise. So there's hope for some of you. Some of you are probably as smart as you're ever going to be. Okay. So let's actually take a moment now to look at the homework while it's all fresh in our minds, and I'll show you which ones you can skip and stuff. So everybody, find the homework. It's under today's date, which is 5-14. Pausing while we ready. Okay, so here we go. On number 1, I just want to warn you, put a star next to C. I notice I'm not crossing it out, but I'm noting that even I had trouble figuring that one out. But try it, then take a look at the key, and you can see how they can make these kind of complicated if they want to. Okay, so you're doing all of number 1, just noting that C is a challenge. Number 2, do all of that, because again, we ask you to do that kind of thing as a part of your tests and stuff. So, all right, so make sure that you know how to do problem 2. And you know what? I can cross off, I didn't do this for the other class, but that's all right. We'll cross off B. I don't think you need to have that many examples of that. That makes A, C, and D all completely different from each other. Okay, now draw those on the little graph thing. So you're making a picture with arrows. You know what I mean? You don't have to label them as column vectors. I'm ahead with you guys because I'm trying to show you kind of like where we're going with this and pre-teach you a little bit so it'll be easier when we get there. On number 3, you may skip C and D. Cod and dolphin are gone. And then on number 5, skip B as in banana. And then we get to this one. And this one, by the way, we are going to skip number 8 there. It's not like it's impossible or anything. I just don't think you need that many. But you should do number 7 and pay especially close attention to whether or not, after you do it and you check it, watch out. Are you that person that had major trouble with the 3D? Because frankly, it probably didn't get all better. If you're a person who struggled with that on the test the last time we had this, it's back. Okay, and if you're the person who was like, oh, those are easy for me, well, awesome, good for you. But if you're the kid who struggled with it, you got to find out, am I still having a hard time seeing, like, for instance, if I take this line right here, and I say, that line that I just made, those 2 lines, when they intersect, is that a right angle? If you can't tell that, that says something about your spatial abilities. And not saying you should go, so give up on this kind. That's not what I'm saying. I'm saying, so try these more than most people. Practice it more if it's your weakness. So is it a right angle? Those 2 blue lines? Yes, it is. All right, here's another one that's similar. I'll just say letters. D to B to C. The black D to the black B to the black C. Is that a right angle? D to B to C. The black letters D to B to C. That is not a right angle. What is a right angle that's near that? DCB, correct, or BCD. That would be a right angle. Does it look like a right angle? Well, to some of you, it's like obvious it's a right angle. And others of you, DBC, dang, that doesn't look like a right angle at all to you. But you got to realize it's part of a box. All right. So on this one, all I'm trying to say is that this will be an easy problem for some of you and a stretch for others. And you just got to be smart about if it's a weakness of yours, you're going to be tested on this. You got to make sure you can handle 3D again and to practice it more than normal. Okay, then the last thoughts that I have before we're done and you get some work time is the lab. It was technically due days ago, but I'm going to give you one last chance to make sure you get a few of the highlights. When it said this, that's not a Z, Mr. Server. There. They were basically saying you should solve that. All right, what would be the first step? add 1. What would be the next step? Z to the third equals 1. Cube root. So that is saying, what's the cube root of what? See what's in there? Is that I? No, that's a 1. So what's the cube root? And that's what they're asking. By giving you that, they're saying, hey, what's the cube root of 1? And is the right answer that it's just 1? No, actually, you know there's multiple roots. That's why when we make a picture of this, it looks kind of like this. This is not exactly right, but close. And then we know this is 1 and 1 and 1. Why? Because it's got a radius of 1. If we take 1 as our starting number, and then we're going to try to find the 3 third roots of it, these are the 3 third roots. That's one of the roots, that's one of the roots, and this is one of the roots. And then the last question, the last question type is, if you generalize this so you don't know how many roots there are, well, then you don't draw the whole thing. Because if you draw the whole thing, you can see how many roots there are. But if you just draw like 2 of them, like this, and then generally say what's the angle, instead of saying that's 120, you say, what's that angle again? 2 pi over n. Then you should be able to generalize how long that line is. How? I did hint at the distance formula because some kids do it that way. I had one kid last hour who did it with the distance formula. That is a distance between 2 points, and it can work. If you're going to do it that way, you'd label this spot as the x is always the cosine, right? And then y is always the sine. That would work if you wanted to use the distance formula, and I gave you that option. But then I said, there's this other formula which we actually wrote down, which was what? Law of cosines. And the law of cosines can be used to generally give me an equation that looks like this. Well, if that's A and that's B, what's the third side called? C. Now, could you change that to D for distance? You could, but you don't have to. You could call this side C. Side C would equal, and I'm not going to give you the answer here, but let's say it was something like this. 2n plus 3 cosine of 2 pi over n. It's not the right answer. But it'll look kind of like that. And then if you've got that formula, you could tell me any number for n. Like, oh, I want 5 roots. And then you should be able to put it in here, and it will tell you what? The number of people living in a hut in Botswana? That's not it. It's the distance between two random roots? No, 2 consecutive. They'd have to be like next to each other. The 2 roots on the circle, so to speak, they'll be next to each other. Because again, if you make 4 roots, for example, and you did it like this, that's impressive. Can you make this that? Thank you. This is not perfect because these are supposed to be 90-degree angles. But if I wanted to get distances between not consecutive roots, then that'd be like, how far apart are those 2? And that's totally different than something like this, which is a consecutive root. And this would also be a consecutive roots. And this would be consecutive roots. And this would be consecutive roots. Okay. That's what you're supposed to do. Make sure you answer all the little questions in the lab. And you're supposed to be putting this one in the format for all labs, which is purpose, then procedure, which is kind of like I generally did this, and then calculations, which is where you actually grind out the solving of that nasty equation and you get it down to just C equals whatever. And then conclusions, where you say, so this is what I learned, and here's some reflections on the math that I could use, that math that I learned. Okay, so that's enough help on the lab. We've had enough time. We've talked about it on multiple occasions now already that tomorrow it's really, really time to grade the lab. Okay. And I've been pre-teaching you so that tomorrow's lessons should be able to be done in just a few minutes, giving us time to grade said lab. Okay. And that's all I have for you for today.